welcome. This is Mike Acton. I am going to talk to you today a little bit about how the DoD has been approaching refactoring mainframes to get more value out of them. So first, I want to thank you for spending some time today learning about system modernization with me. Again, like I said, I'm Mike Acton. I'm a seasoned solution architect, over 25 years of experience. I'm also a certified AWS solution architect. My focus has really kind of morphed from development to modernization over the years, and have quite a bit of experience doing system modernization. As one would expect in the DoD, the portfolio has a number of legacy systems that need to be modernized. So in this session, I will present some information about modernizing mainframe applications within the Department of Defense. And I think this information should be useful in assisting you with similar efforts. There's a lot to be learned here. And what I've tried to do is take a number of our experiences and distill them down into the methods, the practices, the repeatable aspects of it, right? So I think that's a good way forward. My contact information, should you have any questions, is included on the last slide of this presentation. So again, if we don't get to something, feel free to send me an email or whatever. Also, I will, and I'll get this again at the end, but I provided a couple links at the end of the slide deck to give you some really good detailed information, as well as what I'm going to go over here. What I'm going to go over here, we're going to try to keep it a little bit higher level for the sake of time and for the sake of communication and understanding, again, with a varied audience from project managers, program managers, architects, engineers, etc., hands-on people. Okay, so with that said, let's move to the next slide. Okay, the overview. So on the left side, we have two bullets. Those are the bullets that were described in the webinar when you signed up. So I'm not going to read those. You can peruse those if you like. The two bullets on the right side, I do want to spend just a moment on. Again, replaying what I said a little bit. Again, this webinar describes how large, complex COBOL applications can be recast as modern Java applications running in the AWS GovCloud. It doesn't have to be Java, right? There's a number of language targets you can use, actually a wide array of language targets you can use. But we have experience with Java, C#, and some others. Those seem to be the ones that we see, at least in the DoD, becoming the more preferred languages, right? And then there are some of the, scripting languages, et cetera, that are used, JavaScript being a big one. The bottom bullet there, this information is based on a number of experiences, right? I mean, so if you read what I've included in the backups for you, the links, you'll see one experience that was written extremely well, publicly releasable information from DoD. So that it was a lot with a lot of detail in it. Very good. That is one of the experiences. We have some other experiences as well where customers are not just doing code conversions and then rehosting into the cloud, but they're doing other things. This information is based on several experiences. We're generalizing the best practices, hopefully for reusable information. Okay, I don't want to spend a lot of time here because I want to keep this moving for everybody's sake. Okay, so about Array, quick slide. So Array, and we just read expertise, right? We're not going to read the whole slide, but expertise. We're an application services company, and that means that we do anything, or really everything, that has to do with an application. An application in DoD terms can be very large, right? It can be a whole. Some people would call it a system, but we in the DoD we separate the word application as being the business logic, the thing that does the mission, versus the system, which is a lot of the platform as a service or infrastructure as a service, et cetera, right? I mean, clearly we need it all to be together to have that application run. So we're an application services company. Our approach, our method, our key method is agile DevSecOps pipelines. I mean, I think this is pretty common at this point. The third bullet there, application development sustainment. So many of our programs are applications that have been developed some time ago, right? Some a long time ago, some in the last 5-6 years. But what we do as an integrator is we own, if you will, air quotes, own the technical baseline of the application, and then we maintain it, we upgrade it, break fix, but we also introduce new functionality properly, right, carefully, safely and securely, right? So that's a part of the development sustainment effort that we do. Of course, the next, cloud migration and optimization. We do a lot of cloud services. So again, our application has to live somewhere. So we have been doing a lot more of the cloud work, a lot of migrations, a lot of refactoring. Other expertise is legacy modernization. That's why we are good at understanding what needs to be done in terms of mainframe modernizations, refactoring, and rehosting. Cyber solutions, architecture, et cetera. So again, I think you get the picture. We're a pure play, if you will, application services company. That's where we live, and we help the applications modernize from that standpoint. So our agenda, briefly, is we're going to talk about the challenges, the objectives, and we're going to talk about some of the characteristics of the legacy systems that you're going to find in DoD, right? So, and these are pretty common, whether we're talking to Army, Navy, Marine Corps, or Air Force, right? So they're pretty common. Individual objectives, though, vary quite a bit, and that, by program to program, service to service. So we'll talk on the big about that. Solution approach. So we're going to talk about how we go about determining a solution, what methodologies we use, how we determine solution options, how we rule them in and out. And that's an important conversation because just because we picked a solution based on a set of criteria doesn't mean that that's the solution you should pick, right? You should go through the due diligence and process. Next one is customer benefits. So what benefits does the customer see from such an event? Where do they get? Lessons learned, always good. Our contact information, then we'll do some questions and answers at the end. So if you would, hold your questions to the end and we'll go from there. Okay, so let's talk briefly about some of the challenges. So the challenges that DoD faces with respect to mainframe modernization are some of the following, and we're going to go through these. I'll briefly hit on them. This may, if you have a question, again, please submit it, and we'll get to it, or you can contact me. The first thing to talk about is in the DoD, a little bit different, but maybe not that different, is some of the systems are, no kidding, mission critical. And mission critical in DoD terms means that there will be a mission impact. There might be a particular mission that's unable to be completed, and so that's a big deal. So say no downtime, but very little downtime, right? So we can't be down for a month while we're switching systems. We really can't be down much more than a day or two here and there throughout a year without having an impact. And that has to be planned and coordinated so everybody knows it's coming. The second icon there is that this applications you find on the mainframe that are written in COBOL have been highly customized. They've been optimized. There's been years and years of getting more value out of the investment, right? So they're highly customized and optimized. That actually makes them a little bit more, the good thing is the business logic is tuned, the business processes are tuned. The tough part is, though, that it makes them hard to recast as another language or code convert or even migrate because of the customizations. Because when you customize, you're customizing not only software, but hardware, middleware, firmware, network, all of that stuff, so that your users have the best experience and the best possible service. Third one, generally these are closed legacy platforms, whether you're on an IBM, whether you're on a Unisys. I mean, you're getting a relatively closed platform, and there's good and bad to that. Obviously, I mean, there's a reason they're closed. And when I mean closed, it means that it's proprietary from Unisys or IBM, and you're using all of their stuff integrated the way they integrated it. The good is that stuff performs, and the bad is that over time it's more difficult to to upgrade, or certainly to get off it onto a new technology, right? That's tough. Fourth one there is needs to meet the DoD security and auditing requirements. I mean, in DoD we have RMF, we have fire, we have compliance, we have reporting. I mean, all companies do as well. DoD's is pretty stringent though, and we have to put quite a bit of effort to make sure that we're complying with regulations, right? Next one is it's poorly documented. Maybe that's maybe not all poorly documented. They're documented, but you can't find all the documentation you're looking for, right? And it could be the application, or it could be really the system itself, or some of the technology components, especially down in the deep bowels, right? When you need to know exactly how a particular integration is working at a very technical, detailed level, so you can make decision on it or troubleshoot it. That kind of documentation sometimes is difficult to obtain in a clear fashion. Okay, a couple more, and I'll go through these very quickly. Obviously, difficult to obtain developer and admin skills for COBOL, and even more difficult if you're on a legacy platform COBOL, right? Like an old, a quite old platform. Next one, difficult to obtain hardware components. Again, if you're on a very old platform and you've not been able to upgrade, you're kind of stuck. So you need to have hardware and components and integration components, sometimes hard to find. You get very high operating costs because of the previous two things, right? I mean, you have to pay for skills, and you have to pay for those components in a marketplace where those are more rare. Change is difficult. So if you're going to change, the amount of testing, the amount of coordination is a lot more than it is with modern systems using a DevSecOps style agile process, pipelines, and tools. And then the last one there is waterfall methodology, and it almost goes. You can see how these bottom things all fit together. They almost require waterfall because it's difficult to change, because there are high operating costs, because you are having difficulty with hardware and people. So you have to do more due diligence to make sure that the system is going to run and run safely. Okay, so let's go on to the next one. Objectives. So in DoD, what are customers, what are programs, what are functional and mission areas trying to achieve? Well, they're trying to, number one is they want a low risk major upgrade. And I say major, not that it has to be major, but they want low risk upgrades that do not impact the mission. Downtime is absolutely a minimum. That is key, right? Just like if you're running a business, you want low impact to your business. So the next one is that we need to retain all business logic, the reports, everything, right? And so this is important because when you're converting code, there's something about the system that you have that you still like, right? There is functionality in that system that needs to be preserved, that you're not going to get from an ERP or a CRM or redeveloped, right? You've determined that code converting is a smart thing to do. So you're going to retain all that, and we'll talk about that later. It's a very important approach. There's some methods and some processes around the retention of all the business logic that is really good and really helps us make this a lot easier. We want to move to an open platform, obviously. So we want to be on a Linux, or we want to be on a Windows operating system. We want to have access to all of those good frameworks and modern integration approaches, et cetera. Next one, obviously we have to meet the security requirements, goes without saying, but it is a going in requirement, obviously. We want to document the system using as much automation as possible. So something like Java doc, or the similar with C# or whatever language you're using. We want to document as much of the system as we can using automation. And that could even be the way that your application's componentized, et cetera, right? Models, et cetera. So we could run something against the code and get the documentation, again, as much as you can. It's not all perfect. Improve business continuity. So, a lot of the systems we had were running in a data center or two data centers on-prem. The business continuity was more of a warm standby, something that if the primary failed, you'd have to start up the secondary. There could be some data, there could be some time before all the data is caught up and back online. So we want improved business continuity. The bottom couple. So we want to have plentiful technical skills. Obviously, it's a better market, more affordable. We get to get the next wave of technology, right? So for admins, developers, architects, we really want the plentiful skills. We want the modern skills, because that's going to help us beyond just converting, right? That's going to help us take it to the next level later. We want to migrate to virtualized hardware or to the cloud. I mean, so ideally, I think more and more in DoD, migrating to the cloud is the way to go, the more accepted way. Earlier on in DoD's journey to the cloud, I will say from my experience that everybody wasn't sold on the cloud, right? They're because of security, because of the data is now off-prem. In DoD, that's a big deal. It's still a big deal, right? And that's a whole nother webinar and discussion about data security and et cetera. But I think now, because of some of the FedRAMP, some of the DoD authorizations to put data in the cloud, and the accreditations and inspections that have been done, DoD is much more comfortable now than they have been in the past. I'll put it that way. Next one is reasonable costs, and notice I don't say low cost, I say reasonable costs. DoD's, like most businesses, mission first, right? We got to get the mission done, and then we want to do it for a reasonable cost. We realize we're still going to have to pay something, so we're not just trying to wipe out all costs, right? That's not and in fact, on a lot of different DoD applications that have migrated to the cloud, they're not really saving a lot of money. Well, they are saving money, but they're reinvesting that money almost immediately right back into advanced services that they've never had before. So it's not like the budgets are going down, but the capability is going way up, right, in terms of what they can do. So that's what we're seeing there. Easier to change, yeah, definitely. The more rapid response to mission, changing mission requirements and business requirements is clearly what they're looking for. Agile and DevSecOps and pipelines from requirement to release to the user. It's exactly what DoD wants. And I think they're willing to, they want to go fast. Anything you'd hear in Silicon Valley, that's what we're trying to do, or that's what DoD is trying to do, or what they want to do. And we're on a maturity path getting there, right? And there's a lot of investment and a lot of progress towards that goal. And then of course elasticity, right? And all the NIST benefits of the cloud, whether it be metering and pay for what you use, and that ability to forecast your bills. These are some big deals to the DoD, right? DoD isn't there to build systems per se, right? And we do, right? Because we need to, and we have to have trusted people doing it. But DoD is really there to accomplish its missions, right? And the systems that we use support those missions. Again, no different than a big business, but our mission clearly, the DoD mission clearly is a very important mission. So, okay, so let's go on to some of the legacy system characteristics that we see in DoD. So what do we see? We see aging mainframes, right? So DoD tends to buy something, and they are really good stewards of that equipment, and they get a lot of value out of that equipment, right? So they buy it, and they will use it until they make the determination that it is no longer financially viable or functioning properly and no longer viable, right? So so that's kind of where we're at with some of them. We have to replace them because the hardware is old. The software is the wrong paradigm maybe, or an older paradigm, but the software still works very well, right, for the most part. It's but then of course along with aging mainframes comes much larger bills, and then when you start looking at the alternatives, right, if you could just snap your fingers and say I'm off the mainframe and I'm running on x86 in the cloud, bam, 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 that's clearly what people would want. If only it were that easy, but we'll talk about that in a minute. The next one is, obviously I mentioned before, a highly optimized COBOL application over many years and decades. So, this is across the board, right? I mean, DoD does a really good job optimizing their business, right? The third one there is a large, complex code base and database baseline. So, I mean, these things run into millions of lines of code, COBOL code. You need people that can understand the code and the software levels. You need people to understand the operating systems, and the entire software, hardware, network fusion, if you will. On the bottom, couple things to talk about too is our systems in the DoD have mission users located around the world, and they might be directly using the system, or they might be using data that gets extracted and sent to them in some, we'll call it a hot zone, right? So very important that these systems are up and running and available and processing properly, because that data is used to make decisions and to run different missions. Bottom second one there is executes millions of mission critical transactions. So these are important transactions, and just like, again, anything, when you're ordering supplies, or you're doing maintenance, or you're supporting a mission plan, I'll call it that. If you do one thing here and that transaction doesn't complete right, you may affect 4 other things, right? So there's a lot of dependencies on certain missions being able to execute properly, right? So obviously critical. And then these aging mainframes are located on-prem in traditional data centers. And in and of itself is not a terrible thing, right? I mean, but here's the rub. It's certainly not in a data center that's been designed just to run mainframes, right? It's a data center that's running everything, one of everything, and the DoD workforce works extremely hard trying to keep all of this disparate hardware, software, networks running safely, securely, with good uptime and good performance. So it's been a challenge, right? So I mean, that you can see where what the DoD has to deal with here. Okay, let's move into the solutioning part of this. So we saw the problem, we saw the challenges. So what's a solution approach? So the first thing is to really know your customers' objectives. And part of that is you have to understand the long-term goals and timelines of that application, right? Because some applications, it's bare bones and we're just going to sustain it, or we're going to subsume it with something else, or we're going to replace it with an ERP. You have to have that good enterprise architecture, the no kidding enterprise architecture, that it shows the strategy of systems being rationalized, modernized, retired, replaced, whatever it is. And you have to understand where this application fits in all that. And that's important because you're going to be talking about investment decisions, obviously, and solution options that will drive some of that. We'll talk about those just in a minute, about some of the different options you're going to have to handle your application. The second thing is you have to understand the existing application, and you have to understand it technically, not just understand it. You have to understand the functionality a little bit, but you definitely have to understand all the piece parts, the components, the integrations, the networking, the software, the computing services it's using, if it's using any. You have to understand where the IDAM is the identity management is being done, how it's being done, et cetera. I mean, so you really have to understand that existing application in a very discrete manner, right? Also, you see the bottom bullet there, you need to validate information with subject matter experts. So generally what you do is you start out by looking at the documentation that exists. You use some discovery tools to build your repositories or your models, and then you make sure that you validate that information. So that's so now the first two things, you know what your customer really wants, the context, you know what the existing application really is, and maybe you've been working on it, so you really know anyway, but this is it. Sometimes you're not working on that app, you come in and look at it. Third thing there is you develop the solution options. So you need to research, review, iterate, down select a bunch of solution options, right? So you need to identify them. You need to, I even say the word develop solution options, right? And then you analyze any the high potential solution options, and you go through a series of iterations to choose the best option. And this isn't done in a vacuum, right? This is done with technical teams, with a program teams, with a customer. This is a series of reviews, and you can see the bottom sub bullet is review, communicate the results, make sure we get buy-in at the right levels. And then finally, you want to plan and execute the project. And by this time, hopefully you know your existing baseline really well. You know what the to-be baseline is going to be. You've gone through that architecture level, and you start planning on certainly the what and a lot of the how, right? And then you build your project plan from a work breakdown structure, at least at a high level. And then generally we apply this in a pseudo or a hybrid agile waterfall approach, because it is such a big effort. Now, in this case too, we're not talking about a strangler pattern, at least not totally, right? You could use a strangler pattern for elements of it. And in fact, the one paper I reference for you at the end of this brief talks about how they used some methods to isolate the main COBOL mainframe component to do code conversion to that one component. So we're going to hit that in a second as well. So, okay, so let's move on. Here's some solution options. These are general solution options you're going to see across many different, mainframe applications. And again, it all depends on your context and what the customer wants and what you need and what you can afford and what you're going to invest in. But the first thing is to do nothing, right? Well, okay, that's status quo. We have done nothing for many years at this point generally, and we realize it's time to do something. So maybe do nothing's not an option anymore, right? Okay, so let's talk about solution option 1A. Well, how about if we convert the COBOL to Java? So all the COBOL routines become Java methods, and we convert the existing mainframe COBOL database, DMS, to a relational database, and we put that on x86. Okay, so that's one option, one way to go. And now in this option 1A, there's no other changes. That's it. So no function changes, no business process reengineering, none of that. All we're doing is we're going to convert the COBOL directly to Java, no changes. And that means no changes to user interface, data interfaces, absolutely isolate the changes. And the reason for that is hopefully obvious. It's to minimize risk, to minimize the injection of complications any more than you already have. Okay, so option 1B is very similar, right? Again, you see the exact same thing, COBOL to Java, DMS, RDBMS. And then in this case, we're going to use some PaaS services. So we're going to maybe use some IDAM, identity and access management services. We might use some data integration services, et cetera. The option 1B is interesting because ultimately you probably do want to get to using the PaaS services instead of doing that stuff in your code. However, it does introduce more work. It introduces more complexity to already a complex, risky effort. So maybe you want to do that, maybe you don't. Option 2, we could re-platform the proprietary COBOL on x86 using an ANSI COBOL, right? So here we go from the mainframe COBOL application, which is proprietary, right? So say it's a Unisys dialect, and we go to ANSI COBOL, right? So this is a popular thing, and you can see this solution like Micro Focus has a solution for that. So this is one that people consider, and some that in DoD certainly look at and are exploring. I'll put it that way. Option 3 is a total rewrite or redevelopment. So now we're saying, okay, I have a COBOL application on a mainframe, and to modernize that, I'm going to rewrite the whole thing, right? So this one is like automation is maybe too hard, code conversion is not going to work, going to ANSI COBOL is not going to work. I want to go to a new language, a new platform. I'm going to have to rewrite and redevelop. That is pretty tricky stuff, right? Option 4 is we could use some kind of an ERP or other COTS replacement for what you have. But again, this is in a way a rewrite or redevelopment, because you're going to have to blueprint it out. You're going to replace the system with this new system. The new system has to be built at some level, right? You might be able to use some automation for this, but generally with an ERP, as you folks are aware, the ERP has a number of methods already built in. You're going to leverage those methods. Then you're going to customize them with some RICE objects, etc. So that is a tricky one too. Option 5, we could re-platform the existing COBOL on x86 using a third-party emulator. So in this case, for an example, we could re-platform the, say, Unisys COBOL onto x86 using a third-party Unisys emulator, right? Now, if that worked, that would be great. If it were that easy, it would be great, because then your code just ports and you're just using an emulator in x86. But there is a downside to that, is you have to pay for the third-party emulator, and you have to find one, and it's got to be a good one, and all that type of stuff. Okay, and then option 6 is to rehost the proprietary operating system in COBOL to a proprietary x86 hardware emulator. So in other words, the same company, you say you're using IBM and you're running an IBM operating system, et cetera, and they provide you with an IBM certified x86 hardware emulator. And in that case, you could just be able to port your code over, and again, in theory, maybe you port your code, but you still have to port all of the data interfaces. So all of these have pros and cons, and all of these, 6, 7, 8 options need to be considered, along with variance, right? So your mileage will vary, right? You need to make sure that you pick the right options for you. What I'm kind of showing you is a methodology on how one goes about developing solutions, and these are common, but not all. And again, depending on what you're doing for your mainframe in your situation, you may need different options. Okay, now that we have the options laid out, let's take a look at a bit of analysis. So these are the options. You can see in the left column, 0 through 6 there, and I color coded it with like stoplight colors to say what's good, bad, and ugly. And so you can see the green ones were determined, are generally determined in this case to be viable, where the red ones were not viable for some reason. And you can see, and I quickly go through this, do nothing was no longer viable, right? Because the system risk was too much, the application risk was too much. We had to do something. So matter of fact, as soon as we said that's too risky to continue that way, everything else doesn't even really matter, right? We're going to do something. Okay, so that one's off the table. And then we went to 1A, and we said, okay, that's viable. And you can start seeing some of the things we're looking at in terms of viability. We want it virtualized on-prem, so I'm looking at the columns in the middle there. Virtualized on-prem, check, got it. Can it go to cloud? Yes, okay. Project duration, it's going to be medium length duration, right? It's not going to be overnight, because you do nothing that's easy, right? No duration for do nothing, but a little duration certainly for converting COBOL to Java, right? That's if you were just doing this one project, right? And then you can see the refactor and migration cost. Yeah, it's going to cost you some money, because you're going to have to do some conversions. You're going to have to do a lot of testing. You're going to have to do some accreditation work. I mean, there's work to be done here, right? Operational cost when you're done, well, since you're going to basically open source stuff, it's going to be relatively inexpensive. You're going to be in the cloud, relatively inexpensive. Mission risk is medium, right? There is definitely medium risk to do a code conversion. It's not low risk, it's not no risk. It doesn't have to be high risk if you approach it properly. Modern architecture, you can see that we're still not on a modern architecture yet, because we still have a lot of our PaaS services built into the code, right? So we're not quite there yet. And then available technical skills is green. So you go to 1B, very similar. It's going to take longer because we're converting to PaaS. It's going to cost more because we're converting to PaaS. Operational costs and risk are about the same, a little more risky because you're doing a little more work. So that yellow may be a darker yellow, but you are going to be on a modern architecture, et cetera, when you get there. Okay. And then you can see option 2 there is to go to ANSI COBOL. It's viable. And again, you can see some of the same analysis that you go through. And by the way, again, this is an example. The columns you use may be slightly different. Maybe you don't care about modern architecture, right? Maybe you don't care about available technical skills. It was a big deal to the mainframe COBOL that we're doing, but again, this could be applied to different situations, and just swap out the parameters you're looking at and figure out what they mean to you. And then you can see options 3 through 6. 3, a total rewrite and development. That's expensive and risky for a lot of reasons. 4, very similar. It's risky, could be expensive. You're going to have higher operational costs because you're buying a proprietary ERP package and all that comes with that. Number 5. Replatform COBOL using emulators. Again, some of the ones we looked at, they were immature, and there was a lot of things they did not handle from our highly optimized systems, right? So that was an issue. And then number 6, at the time we were looking at these proprietary operating system hardware emulators on x86, they just weren't available. They were starting to be marketed, but they were never generally released or generally available, right? So that gives you an idea of some solution analysis went through. So obviously we're talking about 1A, 1B, and 2 being viable. So we go to some solution findings. So now we're going to next level. We're going to slow down a bit here, and so desired outcomes. If you look at the desired outcome column, it says the shortest project duration is obviously do nothing or replatform to ANSI, right? Again, this comes down to what desired outcome do you want, right? And then you can read the rest for yourself. This is here really just so you can understand these, a way to look at these. And do you want the lowest refactor and migration cost? Do you want the lowest operational cost? So everything's a trade-off. Technology modernization is no different. That's why your planning and your architecture is so important to make sure that you have the right targets going forward. So ultimately, solution 1A and solution 1B are generally selected, right? And you'll see again as I point you to the reference, they kind of chose a 1A, 1B. Not exactly. You got to read their whole story. It's an interesting story, and I say their story. It's a project that Array worked on. We were the prime for that project, so we know a lot about it. But I just want to make sure that we point you to that information because it's well written and it's detailed without being overwhelming. Okay, so let's go on. So this solution with 1A first and then 1B. Remember, 1A is to convert the COBOL to Java, get off the mainframe, get onto x86, right? That's what we're trying to do. And then 1B is the same thing, but then we would replace some of the services with PaaS services, so some of the cloud services, right? Was what we do. So let's look at the diagram here. So on the left side is COBOL. So we have COBOL on the mainframe. Phase 1, what we do is we do a automated refactoring and code conversion from COBOL to Java. And then we have this ugly looking Java, right? Which means that although it's Java and it runs as Java bytecode, right? It runs as Java methods. It really has a lot of COBOL based paradigm and architectural structures in it, right? So we've got to then clean that out. So we go into this phase 2, which is advanced refactoring to remove the COBOL design from the Java code to end up with, after phase 2, this really clean Java, right? So standard Java, that's what you're looking for. And then after that, we would move it to AWS GovCloud. And there's so much to talk about here. I wish we had a lot more time, but let's move on for the sake of time. Okay, phase 1, COBOL to Java code conversion. On the left side, we have the legacy mainframe on-prem COBOL. That's kind of what it looked like at a very simplified level. We applied automated refactoring, a refactor and convert COBOL code to the Java code, and then we can refactor the legacy database to relational database. And that is a tough you know, that we had a team just focused on just that, because you have to get the data right. Obviously, you have to isolate things and get the data right. But then what we ended up with was kind of that ugly Java, which was the modern application with COBOL remnants. And now here, I don't, on this slide, by the way, I don't say the word Java because it's a modern application. There's a lot of targets you could go to. Could be Java, could be C#, could be, you know, there's probably 50 languages that you could go to, right? But you got to plan that out. So okay, so that's step one. And by the way, I want to mention too, we worked with a partner and their tool. They're expert with their tool, a company by the name of TSRI. They do a lot of conversions, but there's other code conversion. If you Google code conversion companies, you'll come up with a bunch of them. Or again, send me an email and I can send you a bunch of them and you can look at them. So okay, so that's what happens here. So that just got us to this modern application. In other words, Java, but there's still some COBOL in it. So this slide, we have, again, we're moving the right to the left, if you will. So from the last slide, the story continues. We have a modern application on x86 on-prem and still has a COBOL remnant. So what did we do? Well, we did some more advanced refactoring. We did these particular specific things. Some are just wrapping up, but refactored COBOL memory model, the Java memory model, refactored control flow logic to eliminate the go-tos, refactored redundant code, right, dead code, whatever, got that out, which is a big deal, by the way. And then refactored the COBOL DMS mapping to native Java and SQL. And then now on the right side, you come up with this modern application, x86 on-prem, you're looking good. You know, things are getting there. Okay, fast forward to the next one. We basically take that nice application we were doing on-prem, on x86 on-prem in our own data center, and then we are migrating that to AWS GovCloud. And then, again, in this case, we weren't trying to do a lot of changes. We were just trying to get it there. And then once it's there, the evolution story will continue using cloud-based services, right? So again, that's a general approach in DoD to get there, is to really manage risk, plan so risk doesn't bite you. And then once you're there and you stabilize, you follow the next part of your plan, right? Which would be to, again, continue to evolve the application. Okay, sake of time, move forward. Some of the solution details, put this in here. Some people are very interested in testing security, data, performance, and high availability. I'll hit these quickly. Testing, number one, risk. I mean, you have to test the code. You have to test every thread of the code. You have to test, et cetera. The good thing is, because we didn't change, or we don't usually change any functionality during the conversion, we can reuse the existing test cases. If they're automated, so much the better, or if they've been automated over time, so much the better. And then you can just rerun them on each iteration, right? And if you're setting up to go into one of these modernizations in the next couple of years, as you do your tech refresh, as you do your testing strategy, you should try to automate as much as you can, or as much as you need, probably, from a test case perspective. And of course, continual testing by the functional SMEs. Security, obviously we have to comply. I think enough said there. There's some details if you want to read what we need to comply with. It's that and more. Data, so clearly we had to replace the COBOL DMS with a RDBMS database solution. And, generally that's what the DoD does. I am hearing some people more interested maybe in NoSQL databases, et cetera, database as a service, if you will, RDS. So that's a challenge, and that needs to be accounted for in your plan. And again, the way that we handle it is we have a separate expert data team to do it, understanding exactly what needs to be done. They work with a code conversion team, so they know what the data is going to look like that needs to be plugged into. We're trying to make no changes to the functionality or the way that it gets processed, at least at first. We want to make sure that we get to the next iteration, we test it out, it's good, it's where we want it, or we can fix it quickly, and then we go down to the next iteration. And of course, data is not perfect. No data is perfect. DoD data is very what's the word? It's very involved, right? So we define most things with data down to a gnat's eyebrow, and the mission is so big in DoD because not only do we have weapon systems like tanks and ships and aircraft and buildups and components and whatever, we also have to move troops, and we have to plan certain ways to do tactics, right? So there's quite a bit of data. Uh, very DoD is very data intensive. I guess I'll put it that way. And a lot of the data that we had originally was defined in COBOL, may not be an object representation. So a lot of work's been done there. It's getting better, not perfect, but it's getting better. It's probably not perfect anywhere. Performance. So obviously the mainframe in app was highly optimized, great, really good for speed, harder to change. The performance in the future for some of these applications will be to use horizontal and vertical scaling along with auto scaling. As well, when I say EC2, I'm talking about using the right machine class for the processing as well, right? So it gives us a lot more opportunity to quickly reconfigure the compute that we're using to optimize what we're trying to achieve. And then of course we can use elasticity to pay for what we need only. High availability, obviously we were on-prem, we were doing on-prem high availability, and COOP is business continuity. Continuity of operations is what COOP means. So we were doing our best within the data centers we were in, but when we moved to AWS, we have better options, right? Because there are standard solutions with availability zones and regions, et cetera, as well as just better options using load balancing, right? So okay, 16. Let's go to 17. So some of the customer benefits. Avoid the hardware and software risk, obviously. Cost savings, and it says up to 83% recurring savings for some customers. Again, in DoD, at first we're not finding that, but again, I think we're getting a lot more capability. I think we need a little more discipline on how we're using the cloud. I had some conversations last week about this with some people, and what's happening is, since we have access to so much more reconfigurable hardware in kind of on-demand environments, right? We're consuming a little bit more, right? I think we will get our discipline down because it's DoD, and we will either achieve pretty good cost savings, or we're going to have a lot more flexibility. We're going to spend more money. We're going to have a lot more flexibility to move our missions ahead faster. So either way you look at it, right? We're going to get more for our money. I guess I'll put it that way. Third one is to modernize to a contemporary application. AWS enables innovation. So once we get to AWS, right, then we can start taking. We're not doing this now, but not across all. But the DoD is very interested in machine learning, artificial intelligence, development kits, blockchain. We're just not there because we have so many legacy apps. Now, some apps are way ahead of others, right? So I'm not trying to say it's, there are some that are really doing some great stuff and are really on the forward edge. And then there's those that are more legacy for the reasons I mentioned earlier that we have to deal with. Other customer benefits, we preserve critical mission business logic. I mean, that's key, right? How do we run that is how you run DoD, right? It's those business rules. Now we can take advantage of the cloud benefits. That's pretty obvious. And this, throughout the process of going from mainframe and highly optimized and risky and hard to find hardware to this more open system, cloudish type of system, it's enabled the transition to agile DevSecOps. So I think that's key. Okay, some lessons learned. Again, you can read these later. I'll just top level these. The first one is code conversion does provide a rapid, low risk modernization approach if done properly, right? And then make sure you pay attention to sub bullets. No business process reengineering, right, while you're trying to do code conversion. It just introduces too much complexity, hard to keep it straight. It's hard for the testers. Then your test cases don't work and your SMEs don't really know what's supposed to come out of it. So I would say convert the code first, right, or do any technical refreshes first, And then once you're there, start getting back into your BPR rhythm, right? Where you have that really good product owner testing, functional community doing that. You can read the rest there. I'm not going to go through those. Second big one on the top is the functional subject matter experts are needed throughout the effort for testing, verification, advising, you name it. They're necessary. You got to plan for that. Not planning for that is planning to have problems, to be honest with you. We've found that AWS services accelerates innovation. So, just the way, again, availability zones, regions, elasticity, auto scaling, just that simplest stuff, RDS, simplest stuff is so much better than what we had on-prem. So, not to mention the myriad of other services we can't wait to use in the future, right? So it's definitely an innovator helping us move forward. Consider moving directly to AWS. So a lot of times what we do in DoD is we do very, very small modernizations. We stay on-prem because it seems to be a little less risky. But now, as I mentioned earlier, the accreditation is moving forward better. So we're getting there where we could just go directly to cloud, right? So we could go from legacy to cloud instead of going from legacy to on-prem modern to on-prem modern to cloud, right? So we cut out some steps, get there faster. Critical lesson learned on the bottom there, bound phases with very, very clear success criteria, and do not take on any extra requirements. Very clear on what you're trying to do. If you don't, you're going to struggle, and you just don't need it. Again, these are complex enough and complicated enough projects. And then finally, agile methods, going fast, seeing stuff fast, getting it back to your test community fast, applying very fast automated testing and subject matter expert checks really reduces risk. Okay, here's some more information I discussed earlier. So a great article, a must read, I think, if you enjoyed or found value in what I was talking about, is this article here, the first one, Lifting and Shifting the Air Force Retail Supply System. It's in the Journal of Defense Analytics and Logistics. There's a link in the deck if you get the slide deck, or you can Google that. And that is a nice, in-depth, full context of a very specific case that I was lucky enough to be a part of. And our partners are lucky enough to be a part of, and a very successful, and you can't say enough good things about the people that worked on that. And then a blog post, this is a blog post that I wrote, similar, it's a simplified or a much simplified version of the article and of the story, looking at more retrospectively, right? So they looked at the entire situation, the context in the article, and in the blog post, it's a simplified view along the lines of what I talked about here today, so you could quickly get a lot of value in the takeaways. Okay, so Array, can we help you? Maybe. We have a Cloud Center of Excellence. We have this particular expertise. We're an AWS partner. We do a lot of DoD stuff. We also do Fed Civ. We also do state and local government. Mostly government is what our business is. But these are the expertise areas we have within our Cloud Center of Excellence, and I won't read those. You can check those on your own. And then finally, we're done. So sorry for my long-windedness. Hopefully this was useful information. If you want to contact us, here's our contact information. Brad Barker is my partner. He's a client executive, so for business contacts, etc. For me, more technical, if you have technical questions, you can just send me an email and I will respond there. So with that said, I'll see if we have some